Good day, civil engineering aspirants. Thank you for being here with us today. I am Mayshalin C., a fifth-year civil engineering student at STI West Negros University. I really appreciated the opportunity to give you this lecture today. So, our topic for today's lecture would be earthquake engineering. So let's start this lecture with a question: what is earthquake engineering and how is it important to civil engineering course? Earthquake engineering is more on analyzing structures such as buildings, bridges with earthquakes in mind. Its overall goal is to make sure that the structures are more resistant to earthquake. One of the major loads na gina-consider in building a structure or in designing a structure is seismic load, which is related to earthquake. So, madamo kita nga loads na gina-consider sa isa ka building, but the major gid nga gina-focusan ta is ang earthquake loads because we cannot determine kung saan o maabot ang earthquake. Unlike sa mga weather, suppose ang bagyo malabot sa muni nga area, but sa earthquake, we cannot predict kung saan o siya maabot. So that's why earthquake loads is really considered sa pag-design sa isa ka building. Parang aton nga mga infrastructures in the future will be earthquake resistant. So if you're going to take up civil engineering, maybe sa third or fourth year nyo, encounter si Structural Code of the Philippines, si building code, so duwa kapit gina sila duwa. So makita nyo da, ang ginamba ko sa inyo subong nga seismic loads. In the future, makilala nyo pag ginang iban ng mga loads kang gina-consider sa pag-design sa isa ka building. So now, I'm going to give you heads up kung ano ang i-discuss ko sa ining lecture. So what I'm going to discuss is the introduction to earthquake-resistant design, the elements of seismology, and the earthquake records and measuring instruments. So under the introduction to earthquake-resistant design is the earthquakes and urbanization, which is, I am going to discuss kung anong ilang relationship, history of major international and Philippine earthquakes. So this is very interesting. A lot of us guys are not aware kung ano ang strongest earthquake in the history of the Philippines and worldwide. So I will be giving you guys details later. So next is the Ring of Fire, which most of us guys are already familiar with. Next is under the elements of seismology, we're going to discuss earthquake faults. How is it nga naging related ang theory of plate tectonics sa earthquakes? So, amo na guys, i-discuss ko muna later. And under the earthquake records and measuring instruments, so I have here 4 instruments nga i-discuss sa inyo, which is the seismographs, accelerographs, seismoscopes, and earthquake networks. And let's proceed to the introduction to earthquake-resistant design. So compared to other countries, Philippines is considered a country with proven but relatively moderate seismicity. However, because of the localization of the seismicity in highly urbanized areas, the effects of earthquakes were often catastrophic. So these risks are localized. Seismic risks continue to cause real disasters since it is virtually impossible to predict or prevent them from occurring, even if the progress that new the earth sciences allows today to limit the effects as well for humans and for the buildings and the infrastructures. So kung mas urbanized ang isa ka city, much better or it is really advisable nga magpatindog sa mga infrastructures nga mas doble ang resistance when it comes to earthquake. Let's take Cebu and Manila as an example sa mga lugar nga may aragid sa mga high-rise buildings. Grabe, kinaka-stricto ang pag-design sila. Kaya syempre, once ganing akong urbanized ganing isa ka lugar, kung mag-strike ganing earthquake, mas dako ang ego or mas dako ang damage. That's why gina-consider gid ang earthquake loads sa mga high-rise buildings. Like, doble gid dapat ang stability because we cannot sure kung saan maabot ang earthquake as what I have mentioned earlier. Think about it. The death and devastation caused by major earthquakes around the world can only worsen in the years to come, as urban development and unprecedented population growth compound the lethal effects of natural seismic hazards, experts say. So this is from BaltimoreSun.com. So I included this in the talk naton subong because I wanted to discuss also kung ano man ang effects ng population sa urbanization. So both of them have a relationship which nga kung mas damo ang population sa isa ka lugar, mas highly urbanize ang isa ka area. Like diri sa aton sa Bacolod, hindi pa man amuna ka urbanized diri sa aton because hindi pa man amuna ka damo ang aton nga population diri compared to Manila and Cebu. Kita nyo to kadamo sa mga infrastructures dito sa ila because mas damo ang ilang nga population. So, amo ning ginahambal sa ini nga statement nga mas nag-worsen ang effects ng earthquake sa isa ka lugar in the years to come because as the time goes by, mas nagadamo ang population. So, that's how population affects urbanization and how destructive earthquake is in an urbanized area. Especially if ang urbanized area na ang ilang mga infrastructures hindi amo naka-stable ang design. So let's move on to the history of major international and Philippine earthquakes. So ang una naton nga pag-istoryahan is the major earthquakes here in the Philippines. The Philippine archipelago was formed as a result of the collision of the Eurasian plate on the west and the Pacific plates in the east, which subsequently also formed the Philippine plate. In other words, the entire archipelago was born out of earthquakes. The Philippines lies along the Pacific Ring of Fire, which causes the country to have frequent seismic and volcanic activity. So, Philippines is a result of plate tectonics. Because of earthquakes, nabuo ang Pilipinas. Philippines experiences earthquakes or frequent earthquakes because we are located along the Pacific Ring of Fire. For now, guys, we're going to talk the history of the worst earthquakes in the Philippines. So first is the 1990 Luzon Earthquake. In 1990 Luzon Earthquake, it was late Monday afternoon when a magnitude of 7.8 earthquake shook Luzon, with its epicenter in Nueva Ecija. So its effects were most felt in Baguio, Cabanatuan, Dagupan, and La Union. So ang iyang epicenter is ara lang sa Nueva Ecija. Pero ang iyang naapektuhan is Baguio, Cabanatuan, Dagupan, and La Union. So it explains, guys, that an earthquake is like tropical cyclones or isa ka bagyo. Kung bagyo, may ara na sa dumata-mata. So, it means dira na siya na-form ang isa ka bagyo. So, pareho lang na siya sa earthquake. Ang epicenter is where an earthquake or an underground explosion originates. May ara siya radius sa iya nga effect. Like, for example, kung epicenter mo is at this area, depende na sa earthquake kung ano kalapad ang iya nga pagyanig. Baguio suffered the most damage. The earthquake collapsed 28 buildings, damaged roads, and caused landslides that blocked Cannon Road and Marcos Highway, the two main roads to access Baguio from the capital. So it virtually cut off Baguio from relief, and the only way to go there was by air. Kita nyo, guys, kung ano kahaso pag-rescue sa mga tao if the two major roads ng isa ka lugar is blocked. So through air pa sila maka-deliver sa relief goods or maka-execute sang rescue operation. So, that's very hassle. Kita nyo kung ano kadako sang destruction sang ginatawang earthquake, guys. Hindi siya lahog-lahog. Kapin pagid kung 7.8 ang iyang magnitude. So, people were buried alive inside collapsed high-rise buildings. Hindi kidyo mapaktan sa mga tao yung may maabot ng earthquake, di ba? So, kita nyo, may mga nagkalamatay pa nga mga tao sa sulod sa building. Some survivors in these buildings were miraculously rescued 2 weeks after the earthquake. International rescue teams left the site assuming there were no more survivors. So in total, the 1990 Luzon earthquake took 2,412 lives and affected an area of 20,000 square kilometers. Next is the 1968 Kasiguran earthquake. So on August 2nd of 1968 at 4:19 a.m., a magnitude of 7.3 earthquake jolted the province, but most of the casualties were in Manila. According to PHIVOLCS, or Philippine Institute of Volcanology and Seismology, the earthquake killed 270 people, one in Aurora, Quezon, one in Guagua, Pampanga, and 268 in Manila. Ruby Tower was a 6-story building in Binondo. It collapsed, burying 268 people inside. Most of the people injured were also occupants of the building. Another building in Manila that collapsed was the Philippine Bar Association building. The Aloha Theater also suffered extensive structural damage. So that's why, guys, ang Ininga earthquake is called the Ruby Tower earthquake because it injured 261 people, all of whom were in Manila. And most of them, guys, nga na-injured are within the facility of Ruby Tower. Next is the 1976 Moro Gulf earthquake. On August 7 of 1976, at 10 minutes past midnight, while people were sound asleep, a magnitude of 8.0 earthquake rocked Mindanao. Its epicenter was detected in the Cotabato Trench, which generated a tsunami. A gulf is a large inlet from the ocean into the landmass, typically with a narrower opening than a bay. So, mas gamay ang opening niya kaysa sa bay. Kung sa bay ya, as in, dako siya ya, ang sa gulf ya, it is an ocean pero mas gamay ang iya nga opening. Kung ang isa ka earthquake is located sa body of water, probably it will cause a tsunami. The tsunami flattened towns and villages along the 700 kilometers of coastline bordering the Moro Gulf in the Celebes Sea. So, it swept away people, animals, and properties. So, kabudlay, guys, if ang isa ka area, or if ang isa ka earthquake are siya lapit sa sea, because it will cause a tsunami. And tsunami is very destructive. As in, because it will wipe a village in just a matter of seconds. It is remembered as one of the worst disasters here in the Philippines, owing to the high number of deaths, injuries, and missing persons it caused. A total of 4,791 people died, 2,288 went missing, 9,928 were injured. Next is the 2013 Bohol Earthquake. On the morning of October 15 of 2013, at 8:13 a.m., a magnitude of 7.2 earthquake struck the island of Bohol. The earthquake also felled national heritage, including the 10 centuries-old churches in Bohol and Cebu. The Church of San Pedro Apostol in Lobok, Bohol, built by the Jesuits in 1602, was reduced to powder and rubble and was deemed impossible to restore. The earthquake cost Bohol and Cebu an estimated 4 billion pesos worth of damages. It also displaced more than 348,000 people. So I remembered when we went to Bohol sa amon nga field trip last November 2019. Nakita ko, guys, nga damo sila churches nga gina-restore, and that was so hard, guys, sa ila, guys, nga side, because 2013 natabo ang earthquake, pero up until 2019 gina-restore nila gyapon ang mga historical churches nila, because Bohol is known to be a place nga damo historical churches. And guys, makita man kami mga dalan pa nga wala na kayo, may mga bridge nga nautod, and may mga churches nga gina-restore hasta subong wala pa sila gyapon nakatapos, guys. Amo na kabudlay i-restore ang destruction sa isa ka earthquake. Maybe sa tam-an katigulang na sa mga churches hindi na guro nakayanan sa stability ng mga churches, that's why nagkalaguba na sila. So, damo kami may nakatuan nga churches nga gina-restore pa lang, and may mga churches nga hindi na gid and very, very impossible to restore. Some 222 people died and 976 were missing. Grabe na subong ang ilang nga preparations especially sa mga sinkholes because Bohol is known to be a place of sinkholes. So, not only lang earthquakes ang ginapreparahan nila, but also sinkholes. They have devices. And also, grabe ang ilang preparation sa mga disasters sa ila. So, amo na ka well-prepared ang Bohol subong, guys. Pero subong okay naman tong ilang lugar and bakita ko man nga nag-aamat-amat na sila bangon. Imagine guys, 2013 natabo ang earthquake pero up until sa 2019 wala pa sila gyapon ka-recover. So let's move on to the 1983 August 17 Lawag Earthquake. The night was shattered on August 17, 1983 at around 8 p.m. when a magnitude 6.5 earthquake hit Ilocos with a reported intensity of 7 to 9. Among the damaged structures were the Lawag Cathedral, Sinking Bell Tower, Santa Monica Church and Bell Tower, and Bacara Church, and probably these churches or these places were historical. And the earthquake caused 17 deaths and 80 injuries and left widespread damage to property. Next is the 2012 Negros Oriental Earthquake. I remembered this earthquake because I experienced it diri man sa Bacolod and I was in my, I think, 3rd year or 4th year high school. Isa siya kalinog nga damo sang aftershocks. On the coastal area's landscape was permanently changed when beaches were elevated a couple of feet above sea level, exposing sandstone and beneath the shore. Major highways in Negros Oriental also suffered extensive damage, paralyzing relief efforts in the affected areas. Water supply and electricity were also unavailable for weeks in some areas. So, ang ginahambal dinira nga major highways, probably amo ni siya siguro ang dalan sa gilhulngan. But diri sa Bacolod, hindi siya mo nakadako gid ang intensity ya. Ang natam-an gid probably is gilhulngan. The earthquake caused by major landslides and huge cracks on highways, killing at least 52 people in Negros Island and Cebu province. While the human fatalities are relatively low compared with the other earthquakes of the same magnitude affecting densely populated areas, the damage it dealt to the infrastructure and surrounding geography was calamitous. Ini nga earthquake, natabo ni siya sa area nga wala masyado population. So that's why mas dako ang iyang hassle ya sa properties compared sa lives sa tao. The 2012 Negros Oriental Earthquake is one of the most studied earthquakes in the country. Its numerous geologic impacts in Cebu and Negros Oriental provided scientists at the PHIVOX vast amounts of data which can help people adapt and to mitigate the effects of earthquakes. As what I mentioned earlier, the coastal area's landscape was permanently changed when beaches were elevated a couple of feet along sea level. So that is very rare, guys, nga maka-experience kita amon na nga earthquake. So that's why, to prepare our country, guys, sa mga amon ni klase nga earthquakes, they took this earthquake, especially ang datas nila, as an example, for their research, para nga ma-mitigate naton ang mga effects ng earthquake sa aton na country in the years to come. Next is the world's biggest earthquakes in history. Earthquakes are caused by movements within the Earth's crust and uppermost mantle. They range from events too weak to be detectable except by sensitive instrumentation, to sudden and violent events lasting many minutes which have caused some of the greatest disasters in human history. What we're standing right now is the uppermost layer of the Earth's surface. Later, guys, I'm going to discuss the layers of the Earth's surface. And what happens during an earthquake? At the Earth's surface, earthquakes manifest themselves by shaking and displacing or disrupting the ground. When the epicenter of a large earthquake is located offshore, the seabed may be displaced sufficiently to cause a tsunami. Earthquakes can also trigger landslides and occasionally volcanic activity. Before anything else, guys, I would like to apologize for the unnecessary background noises nga mabatian nyo later because ang amon nga lugar medyo gawad man kinandi, guys. So pasensya lang, guys, if may mabatian ko mga background noises, just ignore them, guys, and let's just focus on the topic or the topics that I am going to discuss for this lecture. So here are the 10 biggest earthquakes in recorded history. So first is the 9.5 earthquake in Valdivia, Chile on May 22nd of 1960.
1960 emerges as the most disastrous earthquake year of modern times.
Even today, the images, the impact of that 1960 quake in Chile have the power to shock.
Thousands are dead. 1/4 of the nation, over 2 million homeless. Whole cities have been reduced to shambles.
The 1960 quake, about 10 times greater than today's, shook Chile for 11 horrifying minutes and sent shockwaves around the world, triggering destructive tsunamis. 15 hours later, a 35-foot wave smashed into Hilo on the Big Island of Hawaii, more than 6,000 miles away. 1,600 houses destroyed, 185 people dead or missing. A day later, a deadly 18-foot wave slammed into Japan. Tsunamis swept across the Pacific from the Philippines to California.
Along the California coast, it swept in at an angle, ripping coastal installations and causing heavy damages.
It wasn't the worst earthquake ever, but it was the worst ever recorded. For the first time, a quake's tremendous power and reach were picked up by sensors newly placed around the globe to monitor Cold War nuclear testing by the U.S. and Soviet.
Next is the 9.4 Prince William Sound, Alaska earthquake last March 28th of 1964.
In 1964, Alaska was shaken by the largest U.S. earthquake ever recorded. Magnitude 9.2. Shaking went on for over 4 minutes. 143 people died. Total property loss in 2013 dollars is estimated at $2.3 billion. The 1964 Great Alaska Earthquake changed our understanding of earthquakes and tsunamis and had a profound and lasting impact. There were gaping fractures, massive landslides, and the destruction of water mains, gas, sewer, telephone, and electrical systems. The epicenter was in Prince William Sound, 74 miles southeast of Anchorage. The surface was disrupted over an area larger than California, 185,000 square miles. Some areas dropped down as much as 8 feet, and others rose up by as much as 38 feet. Some of the most stunning destruction from the 1964 quake came from subaerial landslides. Extreme shaking led to significant ground failure and liquefaction in Anchorage. Massive landslides struck the downtown area, Government Hill, and in the Turn Again by the Sea subdivision.
Next is the 9.1 Sumatra, Indonesia earthquake on December 26, 2004. So in terms of damage and loss to life, the scale of the disaster caused by the resulting Boxing Day tsunami was enormous. In total, 227,900 people were killed or presumed dead, with around 1.7 million displaced over 14 countries in South Asia and East Africa. The epicenter was 250 kilometers southeast of Banda Aceh, Indonesia, at a depth of 30 kilometers. Several days later, on 28th December, a mud volcano began erupting near Barata. Next is the 9.0 Sendai, Japan earthquake on March 11, 2011.
It was centered about 80 miles offshore, and tsunami warnings went up immediately. In coastal cities, people knew what to do next. Video shows the water rushing over an 18-foot seawall into Kamaishi City. The seawall here was the world's deepest and largest, but not enough for the magnitude of the March 11 disaster. It was the largest quake ever known in Japan, and one of the 5 largest recorded in the world.
Next is the 9.0 Kamchatka, Russia earthquake on November 4 of 1952. This earthquake generated a tsunami that caused widespread damage in the Hawaiian Islands. Property damage was estimated at around $1 million. Some reported described waves of over 9 meters high at Cayena Point, Oahu, and a farmer on Oahu reported the cause of 6 cows to the tsunami, but no people were reported. Next is the 8.8 Biobío, Chile earthquake on February 27, 2010.
One of the strongest earthquakes ever measured, and security cameras captured its 90 terrifying seconds. It struck in the middle of the night. At dawn, the extent of the devastation came into focus. In Concepcion, Chile's second largest city, 70 miles from the epicenter, the earth opened up, tearing apart asphalt and even buildings, toppling bridges, and tossing cars from an overpass. The quake rumbled almost 22 miles below the surface.
If the epicenter was near a populated town, the town would be utterly destroyed. Fortunately, in this case, the epicenter was off the coast.
Next is the 8.8 Ecuador coast on January 31st of 1906. This earthquake caused a tsunami that is reported to have killed between 500 and 1,500 in Ecuador and Colombia. The tsunami traveled as far north as San Francisco, on the west coast of the US, and west to Hawaii and Japan. The tsunami caused roughly 12 hours to cross the Pacific to Hilo, Hawaii. Next is the 8.7 Rat Islands, Alaska Earthquake on April 2nd of 1965. The worst of the damage attributed to this earthquake was caused by a tsunami, reported to be around 10 meters high on Shemya Island. The wave caused flooding on Amchitka Island, caused $10,000 in property damage. So no deaths or injuries were reported. So imagine guys, a 10-meter high tsunami, it will sweep a village for a matter of seconds, guys, as in the kong iyang destruction. Next is the 8.6 Sumatra Indonesia Earthquake on March 28, 2005. This earthquake killed 1,313 with over 400 people injured by the tsunami as far as Sri Lanka. The epicenter was 205 kilometers northwest of Sibolga, Sumatra, at a depth of 30 kilometers. This region, also the site of the 2004 Boxing Day tsunami, is particularly geologically active, with 3 of the biggest known earthquakes having happened here. Next is the 8.6 Assam Tibet earthquake on August 15 of 1950. Proceed to the Pacific Ring of Fire. The abundance of volcanoes and earthquakes along the Pacific Ring of Fire is caused by the amount of movement of tectonic plates in the area. Along much of the Ring of Fire, plates overlap at convergent boundaries called the subduction zones. That is, the plate that is underneath is pushed down or subducted by the plate above. As rock is subducted, it melts and becomes magma. The abundance of magma so near to Earth's surface gives rise to conditions ripe for volcanic activity release. The Pacific Ring of Fire are the areas on which the most active volcanoes are present. So Philippines lies along the Pacific Ring of Fire. That's why we experience earthquakes and volcanic eruptions. So in the Philippines, we have 2 active volcanoes, which is the Mount Pinatubo and Mount Mayon. So that's why guys, mga countries like Hawaii, Puerto Rico, Chile, Indonesia, Japan, Philippines, and so on and so forth, maka-experience ng frequent earthquakes. So these are the facts about the Ring of Fire. The Ring of Fire is home to 75 of the world's volcanoes and 90% of its earthquakes. The Ring of Fire is a direct result of plate tectonics, the movement and collisions of lithospheric plates. So lithosphere is the outermost layer of the Earth's surface. The Ring of Fire is roughly 25,000 mile chain of volcanoes and seismically active sites that outline the Pacific Ocean. Also known as the Circum-Pacific Belt, the Ring of Fire traces the meeting points of many tectonic plates, including the Eurasian, North American, Juan de Fuca, Cocos, Caribbean, Nazca, Antarctic, Indian, Australian, Philippine, and other smaller plates, which are encircle the large Pacific plate. The plates are constantly sliding past, colliding into, or moving above or below each other. So, depende na siya sa cases ng movement of plates. Probably, the movement results in deep ocean trenches, volcanic eruptions, and earthquake epicenters along the boundaries where the plates meet, called the fault lines, which we're going to discuss later. The Ring of Fire is home to the deepest ocean trench called the Mariana Trench. So it was caused by the collision of two tectonic plates. So it was pushed under another. The tectonic activity along the Ring of Fire also results in about 90% of the world's earthquakes, including the Valdivia Earthquake of Chile in 1960, the strongest recorded earthquake at 9.5 out of 10 on the Richter scale. So now we're in the elements of seismology, earthquake faults, and theory of plate tectonics. Fault in geology is a fracture along which the blocks of crust on either side have moved relatively to one another parallel to the fracture. Earthquakes occur on faults. Strike-slip earthquakes occur on strike-slip faults. Normal earthquakes occur on normal faults. And thrust earthquakes occur on thrust or reverse faults. When an earthquake occurs on one of these faults, the rock on the other side of the fault slips with the respect of the other. So the fault surface can be vertical, horizontal, or at some angle to the surface of the earth. So the slip direction can also be at any angle. Energy released associated with rapid movement on active faults is the cause of most earthquakes. Faults may also displace slowly, but a seismic creep. So here are the different types of faults.
Faults. A fault develops where a rock structure is broken and forcibly displaced. The movement along a fault may be vertical, horizontal, or a combination of both. A normal fault develops from tensional stress, the stress that results when a landscape is rifting or pulling apart. Movement along a normal fault is predominantly vertical, although the orientation of the fault plane may not be perpendicular to the surface. As the landscape is extended, notice that one side of the fault plane drops down relative to the other. The fault scarp formed along the uplifted mountain front eventually erodes away, leaving little surface evidence of the fault. Many landforms can develop from normal faulting, including tilted fault block mountains, downdropped basins known as grabens, and uplifted mountain blocks called horsts. Reverse fault develops from compressional stress. Movement along a reverse fault is also predominantly vertical, although in a type of reverse fault known as an overthrust fault, the upthrown block overrides the downthrown block at a very low angle. As the landscape is compressed, one side of the fault is pushed up over the other side. Once faulting ends, erosion gradually wears down the uplifted mountain. A strike-slip fault develops from shear stresses, causing one side of the fault to move horizontally past the other. Notice that horizontal movement along the strike-slip fault may displace the course of a stream. Such offset streams commonly develop from ongoing displacement along a strike-slip fault.
What you're seeing on the screen right now is the Pangaea. So it assembled from early continental units approximately 335 million years ago, and it began to break apart about 175 million years ago.
The idea that our planet's continents drift around the globe, periodically glomming together and breaking apart, is at least 200 years old. But most geologists didn't believe it until the 1960s, when mounting evidence made it clear that the Earth's crust is broken up into fragments, and that those fragments, called tectonic plates, are moving. And these days we directly track that motion, with millimeter precision, from space. The common simplified explanation for why tectonic plates are moving is that they're carried along on currents in the upper mantle, the slowly flowing layer of rock just below Earth's crust. Hot mantle rock rises from the core and moves along under the crust until it grows cool and heavy and sinks back down again. Some of Earth's plates, it turns out, are pulling
Before
themselves.
nahati sa 7 continents ang world, we have Pangaea. And the separation of 7 continents of the world is a result of plate tectonics. So that's why I included Pangaea here on the discussion.
This is called tectonics. Plates move slowly, as fast as growing fingernails. Continental plates form the land the continents are on. Plates that are covered with water are called oceanic plates. They are thinner and the rock is heavier. When continental plates collide, the folds can pile up and create huge mountain ranges up to 8 kilometers high. An oceanic plate pushes itself under a continental one. It disappears into the Earth's hot mantle, creating an ocean trench up to 8 kilometers deep. On its way down into the mantle, the oceanic plate melts. But the liquid magma can return to the surface at another place. A volcano is born. When 2 oceanic plates move apart, the seam is called an ocean ridge. Magma from inside the Earth escapes here. This drives the plates further apart and makes them grow. Plates that glide past each other can get tangled up and stick. When they separate, the Earth shakes.
In the previous videos, guys, na-witness nyo kung ano ang concept sa theory of plate tectonics. So, the Earth's surface may seem motionless most of the time, but it is actually moving ever so slowly. So, according to my research, nga ang kada plate, it will move 4 to 5 centimeters per year. So, amo lagi na kagamay, relatively gamay ang iya nga movement. And on the left side, you could see a picture of the layers of the Earth's surface. So where we are standing right now is at the lithosphere, which is the uppermost part of the Earth's surface. And it is divided into 2, which is the continental crust, which we're standing right now, and the oceanic crust. And below the lithosphere, here's the asthenosphere. But what makes the continental plates move is the upper mantle. And ang pinaka-innermost surface ng Earth is the core. So which means dira init-init na siya, guys. And ang upper mantle kagang lower mantle, dira na siya ga-exist ang lava nga gakakitaan naton sa mga volcanoes.
Let's move on to the earthquake records and measuring instruments. So we have here seismographs, accelerographs, seismoscopes, and earthquake networks. Here are the sources of seismic waves. Earthquakes is one of them. Volcanic eruptions, weather and ocean waves, meteorite impacts, cultural activities, and underground nuclear explosions. Seismic monitoring is a term on which ginamonitor naton ang seismic activities that is present on an area or a certain area. Yeah. So, seismology is a fundamental tool for investigating the kinematics and dynamics of geological processes of scales, or at all scales. So, it involves the propagation of seismic waves through the Earth. It provides detailed measurements made at the surface that suggest or imply what is happening at Earth. So that's why may ara kita mga measuring equipments that will record the seismic activities experienced. On the right picture shows how seismograph accepts the data made by a seismic activity. Let's move on to the seismograph. It is an instrument used to record the motion on the ground during an earthquake. They are installed on the ground throughout the world and operated as part of seismographic network. So the earliest seismoscope was invented by the Chinese philosopher Chang Heng in AD 132. This did not, however, record earthquakes, but it only determines if there is an earthquake occurred or The first seismograph was developed in 1890. The seismometer, together with the unit recording the signal, is called a seismograph. The seismometer senses the ground vibration and converts this to signal that can be recorded. Ang seismometer, amo na siya yung recording unit sa mga seismic waves nga gaka-experience sa ka-area. But what makes the waves is the seismograph. It converts the seismic activities into waves. So seismographs can detect, amplify, and record ground vibrations too small to be perceived by human beings. Modern seismographs can measure movements smaller than 1 nanometer. Ang pag-perceive sa seismograph, hindi lang siya X and Y axis. Because ang aton nga surface is not only 2-dimensional, but it's 3-dimensional. So, amo na siya ang gina-perceive sa seismograph. Next is accelerometer. Accelerometer is an instrument for recording the acceleration in velocity of earthquake vibrations. They are usually constructed as a self-contained box, which previously included a paper or film recorder or an analog instrument, but now they often record directly on digital media. Accelerographs are useful for when the earthquake ground motion is so strong that it causes the more sensitive seismometers to go off scale. There is an entire science of strong ground motion that is dedicated to studying the shaking in the vicinity of earthquakes. So roughly within about 100 km of the fault rupture. So amo na siya ang makuha sa accelerometer. Mas lapad kag mas exact ang data nga makuha sa accelerometer compared to the seismograph. Just to be clear, accelerographs do not measure earthquakes. They measure vibrations. Next is a seismoscope. According to my research, seismoscope is more on ancient type of earthquake equipment that has made like 132 CE, layo na gid katama. So, seismoscope is an instrument for recording only the time or fact of occurrence of earthquakes. Made no time record of ground oscillations but simply indicates that shaking has occurred. Hindi yan ma-determine ang intensity kag magnitude ng isa kang earthquake, but it's more like an instrument that will determine nga ay hala naglinog. Pero hindi nila mabalaan kung ano kakusog sa linog. It was cylindrical in shape with 8 dragon heads arranged along its upper circumference, as what you can see in the picture, each with a ball in its mouth. So, may ara siya do bulubulitas sa mga bakba sang kada dragons. It has 8 dragons, and also around the lower circumference were 8 frogs, each directly under a dragon head. So, may naganganganad na mga frogs below sa bakba gid mismo sang dragons. When an earthquake occurred, balls were released from a dragon's mouth, probably by an internal pendulum that moves back and forth according to the direction of vibration. So, and were caught by a frog's mouth, which produced noise. So, that's how seismoscopes work according to a Chinese scholar, Zhang Heng. So, next is an earthquake networks. It is defined as a group of stations working together jointly for data collection and analysis. So, seismic stations operating independently can be considered a network if the data from these stations are joined and processed together. Today, most seismic networks have station linked in a communication network so data is transmitted to a center in real time. Earthquake networks are centers in which nag-accept sila sa data, and if there's any hazards na kailangan ihambal sa public or kailangan i-warn sa public, they send it via internet or via text. If may mabatunan ka mga text regarding a place nga kung sa diin may earthquake, kag gina-warn kita na permi. Probably may mabatunan ka mga warning text coming from NDR or MC. So that is a good example of earthquake networks. The purpose of earthquake networks is primarily to locate earthquakes and determine magnitude. The earthquake location generally requires 3 or more stations. So here in the Philippines, we have PHIVOLCS, or Philippine Institute of Volcanology and Seismology, which is a service institute of the Department of Science and Technology, or DOST, that is principally mandated to mitigate disasters that may arise from volcanic eruptions, earthquakes, tsunami, and other related geotechnical phenomena. So that concludes my discussion about earthquake engineering. It's not the exact introduction talaga to earthquake engineering, but I just gave some pinpoints kung ano ang mga nagaka sa earthquake, kag kung ano ka-important sa earthquake engineering when it comes to civil engineering course. And also sa field man sa civil engineering. If you have any further questions, you could message me on my Gmail here. Cedric ko lang butang ako ng Gmail. Feel free to ask questions and I am willing to answer all of them. Okay? So before ending this discussion, I would like to give a short quiz to determine kung ano ang natunan nyo sa ining lecture. So it's just a short quiz. Hapos lang niya guys, don't worry. Kung namati ka mo, hapos lang niya siya. So here you go. And thank you so much to STI West Negros University for giving me an opportunity to share my knowledge. Halong kamutanan guys! Stay safe, stay at home if hindi man naman naka-importante inyong lalaktan. And always observe safety protocols and social distancing, okay? Thank you so much for listening and I hope you guys have a wonderful and blessed day. Goodbye!